Good morning, good morning, good morning, good morning. How is everybody doing today? All right, so now it is time to move on from definition 5, surfaces, to definitions 6 through 10. But first, some quick review. You will remember from our last lesson that a point is that which has no part. So here is my point. That is, a point is, in other words, location without extension. Which that's a fancy way of saying location without length, width, or depth. All right, after that, a line is length without width. So we get to add one form of extension. You can add length, but you don't have any width. After that, Euclid wanted to tell us that the extremities of a line are points. So at each end of the line here are points, locations that I have no actual, have no extension, but there is location at each end of a line. And that a straight line is a line which lies evenly with the points on itself. So there are all these points you could imagine along this line. And if all of those points, it's the same, the angle above that line from one point to another and the angle below that line from that point to another are exactly the same, then they lie evenly, and that's what makes it a straight line. And finally, we found out that a surface is that which has length and width only. All right. So today we are going to move on and we are going to add definition 6. Here we go. You ready for this? Definition 6 is the definition of the extremities of a surface. Extremities of a surface. Okay. So, I'm going to make this, start making these text boxes a little bit smaller. So, according to Euclid, I'm going to take a second and see if you can guess. We have a hint here. So before I tell you what Euclid says the extremities of a surface are, let's look back at definition 3 and notice that the extremities of a line are points. And then let's think about definition 5 and notice that a surface is that which has length and width. So if the extremities of a line are points and a surface is that which has length and width only, then the extremities of a surface... All right, I have no idea whether you answered correctly or not, but here's the actual answer according to Euclid. And remember, extremities of a surface are lines. All right, sort of straightforward here. All right, so let's take our surface, pop it in here. So here's our surface. You'll notice that a surface has 4 extremities. A line has 2. If this was the line, this would be one extremity, and this would be the other. And those little circles, we could say, are the points at the extremities of the line. But a surface has at least 4, well, at least 3. Technically, you can have a triangle as a surface. We can throw one of those in there just to keep this, keep that in mind. So here's a triangle. We're going to see a lot of triangles in the coming days, by the way. Here's a triangle. It's a surface that has 3 extremities. That extremity, so an extremity really is just a border or an end, is what the word extremity means. Hold on, I'm going to take a sip of coffee. That's some hot coffee. Okay, so the extremities of a surface are its edges. This surface here has 4 edges, right? So 4 extremities. This surface has 4 extremities, and those extremities are lines, right? Because the extremity has it has length, but it has no width and it has no depth. So it just has length. So the extremities of a surface are lines. All right, not too difficult. Let's go on to the next one. We're going to get some complicated ones in these 5 definitions, but that one I think is pretty straightforward. Definition number 7 is the definition of a plane. I can't type today. Plane surface. All right, so a plane surface, according to Euclid, I'm just going to give you the definition first, and then we'll give you some illustrations of it. All right, so let's just throw this one out there. This is a bit of a longer... this one's not too long. Euclid says that a plane surface... A plane surface is a surface which lies evenly with the straight lines on itself. Now, this might seem a little bit complicated, but in fact, this is pretty straightforward. What we're talking about here, and if you remember, this will be it's helpful if you go back and you remember the definition of a straight line. So back in definition 4, we had a straight line is a line which lies evenly with the points on itself. And a plane surface is a surface which lies evenly with the straight lines on itself. So if we had a wavy surface, this might be easier if we add some dimensions to it. So you might want to grab yourself a piece of paper and make it wavy, right? So you can kind of push the two ends of a piece of paper together, and you get some bubbles in it, not some waves, some up and down waves in it. I will let me try to draw that for you here, right? So a wavy surface, if we're looking at it from the side, might look like that, right? That's not a plane surface because, and remember, we're looking at this from the side. Here, let me make this a fun three-dimensional surface here. Where's my little pen? Here we go. All right, so if this was okay, this is a pretty bad drawing, but that didn't work. But you can see kind of where I'm going with this. Beep. And one more time. No, that's not right. Anyway, you know what? Let's try this again. Sorry, you had to watch me do bad drawing, but let's do this right. In fact, let's do it. I can do this really easy. No, that's not what I wanted to do. I wanted to do this, and I wanted to do shapes, and I want to do. I can use this one. And I want to do so there's my wavy surface. Watch this. This is cool. I can now copy that. I can copy that. And see it make a three-dimensional picture of a wavy surface. All right, so we're going to do this. There we go. And then I just need to connect this with these lines. No. You go there. And I'm going to copy that and paste it, and it's going to go also here. Boom. Boom. And all of a sudden you can see, oops, no, that's not quite right. There we go. And you can see there's a wavy surface, right? That is not a plane surface. You want to see something cool you can do with PowerPoint? I can do this. Boom, boom. Select all of those, and I can, let's just do it this way. Select them all, right-click, and I can group them. So now that turns it into one shape. All right, so that's not a plane surface. This is a wavy surface, right? All of the lines, you can imagine, here's a line on it, and here's another line on it. We could do other lines on it. In fact, let's put another line on it just so you can see one. Here we go. There's another line on this surface right there. All right, all the lines on this surface they do not lie evenly with all the other straight lines, right? So the angle from this line to this line is different from the angle from this line to this line underneath. So if you go on top, it's a bigger angle than if you go on the bottom. Therefore, it's not a plane surface. However, if we were to make a plane surface, which we can do really easily, and again, we're going to use the illusion of three-dimensionality here. So let's do a plane surface. Plane surfaces are really easy to do because then you just copy it, paste it. There we go. Nice surface. And then we'll do another line. Oh, I didn't mean to do that. Let's undo that. And now let's do another line, and we're going to do from there to there. And we're going to copy it. Oh, nope, that was the wrong button. We're going to copy it and put, all right, and there. This is a plane surface because any line on it, let's put some more lines here. All right, there's another line on it. Here's another line on it, right? So there's lines on the plane surface. Any line, it's the same angle from this line to this line if we go above, or go over the top, and as it is if we go underneath. So they all lie evenly with each other, and therefore this is a plane surface. And I know what you're probably thinking right now. You're thinking, what is the difference between a plane surface and a flat surface? And the answer is nothing really. For our purposes, there's really not much of a difference. Euclid just wanted to use the term plane surface, so we're stuck with it. But the fact of the matter is there really isn't a difference. So let's go ahead and just remind ourselves that this, and that should be red, don't you think? Red just seems like the right color for that. Boom, there we go. That is not a plane surface. This is a plane surface. Ta-da! Okay, let's go on to definition 8. Definition 8 is the definition of a plane angle. See, the nice thing about using plane, so you can't say it's a flat angle, but we get to use the same term. plane, and you'll see how and why that works here in just a second. This one is a little bit of a longer definition. So according to Euclid, a plane angle is the inclination to one another of two lines in a plane, which meet one another and do not lie in a straight line. All right. Now, there's a lot to it, but I think we're going to take this apart. We're going to look at this one piece at a time, and you're going to see that this is actually a pretty straightforward definition that Euclid is giving us here. Okay, so let's do it. So let's start with a plane. All right, Euclid says that it has to be two lines in a plane. So let's make a plane. No fill. Here's our plane. There we go. All right, so there's our plane. We're looking at it from the top this time. So just right there, looking at it, there's the plane. Sip of coffee. Coffee sipped. Okay, so two lines in a plane, and I'm going to go home here. Oh, no, I don't want to go there. I want to go there, and I want to, here we go. I want to highlight. So in a plane, we've got that taken care of. All right, so now we need to put two lines in our plane. So let's go ahead and get some lines, and let's see here. We can make this will be a fun line. Right there, there's a line right there. See that line? It's a neat line. I like it. We can call it Hubert or Humphrey. Let's call that Humphrey the line. And then we need another line because we needed two lines. So let's try another line. We can do one that does like this. All right, and we'll call that line Gus. So Humphrey and Gus. All right, so Humphrey and Gus here are our two lines, and they are in a plane. Let's make them bigger because we got the space. Why not? Come on, Humphrey. There's Humphrey. Let's make Gus a little bit bigger. Gus, there we go. That's nice. Okay. And yeah, we'll do it this way. Okay, that's fine. So here's Humphrey and Gus. So Humphrey and Gus are two lines. We've gotten that taken care of now. Two lines in a plane so far, which meet one another. Hey, look, Humphrey and Gus do meet one another. All right, so Humphrey and Gus meet one another. And do not lie in a straight line. I'm going to come back to that in a second. But let's. So we're going to put this on pause for just a second. Let me highlight that a different color, so we can put that on pause. We're not there yet. We're going to look. A plane angle is the inclination to one another of two lines in a plane which meet one another. We'll get to the do not lie in a straight line in a second. Okay. So what's a plane angle? Well, that means the inclination to one another of these two lines. So there are four plane angles here on this plane. Two plane angles on this plane. This one right here, this one right here, this one right here, and this one right here. Or if you wanted to make it fancy, we can just do it this way. And this is probably the way you've seen it in your textbooks before, if you've done this sort of work in a textbook. All right, so there's that. Let's take out the fill. We never want any fill with these. Black outline, and all of a sudden, right? So there's an angle, there's an angle, there's an angle, and there's an angle. So we can give them numbers or letters. It's traditional to give them letters. Let's give our angles letters. We're going to call this one, and this is really exciting. You're going to be very impressed with my originality here. We'll call this one angle A. We're going to call this one. Come on, where's my move tool? We're going to call this one angle B. We're going clockwise here. We're going to call this one, anybody want to guess? Anybody want to guess? You got it, angle C. And we'll call this last one, here it comes, angle D. Okay, so we have four plane angles here. All right, so that's plane angle, inclination to one another of two lines in a plane which meet one another and do not lie in a straight line. It's time to let's deal with why can't they lie in a straight line. Well, it'll make sense as soon as you think about it. So now, of course, these lines can't lie in a straight line because they're not straight lines. You don't need straight lines to have angles, by the way. Although it makes life a lot easier if they are straight, I'll tell you that. All right, but let's put two lines in a straight line and see what happens to them. So here's a line, boom, right? We'll call her Wanda, and here's another line. And we'll call her Esmeralda. So here's Wanda and Esmeralda, and there's there's 4 plane angles. That's easy. They're straight lines, but they do not lie in a straight line. They just happen to be straight lines. They are 2 lines in a plane which meet one another. So here they are. Esmeralda and Wanda meet one another. Another nice, easy, nice, straightforward, easy set of plane angles. Boom. Oh, no, that isn't. Well, the angles aren't quite right. But here, you want to have fun. Watch that. We can make this work. Whoop. Yeah. And there we go. Now we got 4 plane angles. Isn't that exciting? Just playing around with it. Okay. So far, so good. Still works great. So why can't they lie in a straight line? Well, let's put a straight line and have them lie in it, and you will suddenly see exactly why they can't lie in a straight line. All right. So here's a straight line. All right. And we need to have Wanda. And we need to have Esmeralda lie in that straight line. So Wanda, you lie in that straight line. And Esmeralda, you lie in that straight line too. Boom. And down, girl. All right, there we go. And as you see, there we go. And as you see, they vanish. Now they're there. You know they're there, but they're touching, right? They meet one another. They overlap. But because they lie in a straight line, there's no angle there. There's no angle at all. The angle between Esmeralda and Wanda is 0. There's no angle at all. So you don't have 2 lines. So you don't have a plane angle. There's no plane angles to make. And that is the reason why 2 lines. When you have a plane angle, you can't have 2 lines. When you have a plane angle, you can't have your 2 lines lying in a straight line. They can't. They just doesn't work. You end up with just a line and no angles when you do that. All right. So that's plane angles, and that's definition 8. We got 2 left to go, and I think we can make this. All right. Let's do definition 9. Definition 9 is the definition of a rectilineal. A rectilineal. And here's how Euclid defines a rectilineal. He says, and, he's sort of continuing his sentence from before for definition 8. He says, and, when the lines containing the angle are straight, when they're straight, comma, the angle is called rectilineal. Okay. Period. So, the trick is, we already had a rectilineal angle. Our Esmeralda and Wanda angle was rectilineal already, and we didn't realize it. Well, I realized it, but I hadn't told you. So let's just steal our rectilineal angle from definition 9, and there we go. So as long as the angles that we're talking about, as long as the lines that make up the angles are straight lines, then the angles are automatically rectilineal angles. I'm just moving. Oh, I didn't want to do that. Just moving this around because I want it to be prettier. There we go. Isn't that nice? All right. So now we have 4 rectilineal angles, A, B, D, and C. However, over here, we should change this. It's bad. It's bad form, by the way. A, B, C, D. You're supposed to use. If you're using, when you have different angles, you always got to give different angles, different letters. E, F, G. We should do it this way. And H. All right. So angles A, B, C, and D here are not rectilineal because these aren't straight lines. But angles E, F, G, and H are rectilineal because they are straight lines. So far, so good. I hope that makes sense because we are moving on to definition 10. Definition 10 is the longest. Oh, not definition 20. Can't get ahead of ourselves. Definition 10 is the longest definition so far, and it is the definition of a perpendicular. All right. So how do we want to define a perpendicular? Well, here's how Euclid goes about it. He says, when a straight line is set up on a straight line, not is set up, when a straight line, comma, I think. Nope, just when a straight line set up on a straight line makes the adjacent angles equal, makes the adjacent angles equal to one another. All right, work with me here. Comma. Each of the equal angles, not angels, is a right angle. Each of the angles is a right angle, and the straight line standing on the other is called a perpendicular. It's called a perpendicular to that on which it stands. Okay. Now, something you might have noticed is that actually Euclid's cheating here just a little bit. And I say he's cheating because he actually is giving us two definitions and just calling it one definition, because he also is defining a right angle. So let's go ahead and we can make that in italics, and let's add it up here. We're gonna tell the truth even where Euclid was being a little bit shady. So we're doing perpendicular and right angle in definition 10. Okay. This is actually not too difficult. So again, we're going to need our let's go ahead and just take all of this. Oh, we can do it this way. Boom. Select it all. Copy it. And we're going to put it in here. Oh, there we go. We're going to put it in here. Let's shrink. Oh, yeah, we can do that. Shrink that a little bit. I don't know what happened there, but that's fine. We're going to play with this around this anyway. Okay. So here we go. So let's do this. Okay. So we're going to, when a straight line set up on a straight line, so we need two straight lines. We're going to set one up on the other. What does it mean to set it up on the other? Well, it just means one is standing on the other one. So when a straight line set up on the other, let's do it like that for right now. Straight line set up on a straight line. So far, so good. So let's highlight that. Straight line set up on a straight line. Back to yellow. Makes the adjacent angles equal to one another. Now, at this angle, adjacent means next to each other, right? So this angle is not equal to that angle, right? They're not equal. So far, we're not doing it right. We're going to do this right. We're going to make these two angles equal, and we can do that because PowerPoint has this neat ability to just snap in at right angles. So we're going to do that. Boom. There we go. When they're equal to one another, so they are now. Highlight that. Each of the equal angles is a right angle. So now we know that's a right angle. We'll call it angle A is now a right angle. And angle B is a right angle. Angle C, by the way, is sort of a thing, sort of not a thing. There's not really an angle C here because this is just one line. Okay, so we're going to leave these here. Okay. So here we go. Now, and there it is, right? Angle B and angle A. If angle B and angle A are equal to each other, then they are right angles. And of course, if you're looking at this, this might look a little bit funny to you because we have a special way of drawing right angles, indicating on paper that we're dealing with right angles. And that is to use a different shape than we use with non-right angles. There's a very special shape for right angles, and we use a sort of square. You remember what this looks like. Let's put one in there. All right, we draw it like this. All right. And no, we don't want any fill. And we do want the outline. There we go. All right, and all of a sudden, that looks right, doesn't it? Because when you use this sort of, to say it's a right angle, you do a little square shape instead of doing a little circle shape, instead of a little curve shape. I don't think we're going to use angles D and C for this illustration, so let's go ahead and delete those. Delete. 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 Okay, and there we go. Now we have two right angles. So each of the angles is a right angle. We got that taken care of now. We know that's true. And, this is important, the straight line standing on the other, this is the straight line standing on the other, is called perpendicular to that on which it stands. So if this is, let's see, this is Wanda and this one's Esmeralda, if I remember right. Wanda is perpendicular to Esmeralda because, and she's perpendicular because angle A is equal to angle B. So let's go ahead and put that, we're going to write that up here, in the form of a sort of a logic statement. So if, that's not the word if, let's see if I can find my angle sign, because there is one on the keyboard, and I just got to see if I can find it somewhere around here. Come on, there it is. If angle A is equal to angle B, angle A is equal to angle B, then they are right angles. Actually, that's not quite true, right? It also has to be and the lines that make them up are perpendicular and straight, then they are right angles. Right? Does that make sense to everybody? I hope it does, because that is our last one for today. I'm going to leave that on there. So, if angle A is equal to angle B, and the lines that make them up are perpendicular and straight, then they are right angles. A and B are right angles. And that's all we got. We now have a perpendicular, it's called a perpendicular. We have now perpendicular and right angle have all been defined. I'm going to go ahead and take away my highlighting here. Boom, boom. Nope, no, I wanted the opposite of that. And now let's just do that again. And boom. All right, so I hope you you've enjoyed this. We are now about halfway there. We're going to ramp things up a little bit next class, and I think we're going to do 6 definitions instead of 5, because we got to get to 23 and just to make this work. So we're going to do 6 this time and 7 the next time. But that's it for today, and yeah, I hope you enjoyed it.